All right, I think we're good to get started. So, everyone, great to be here again, and great to see all of you here again. And it's been 2 months since the last meetup. We've been pretty much trying to do our best as well to have continuous monthly schedule. But yeah, pretty much it's going to be like a one-off thing. But if nothing else, pretty much that comes up, we should be expecting to meet here next month as usual again. But yeah, like how's everyone doing? Everyone good? That's good to hear. So yeah, again, really great to be here back with all of you, the Python community. Always great to pretty much be back here and yeah, pretty much just listen to some great talks and have some good discussions again. And yeah, great to see some familiar faces, some new faces as well. So pretty much I'm just gonna kick it off. So before I kick it off, I'm just going to quickly make a knowledge of the country. I begin today by acknowledging the traditional custodians of the land on which we gather and meet today and pay my respects to the elders past and present. I extend that respect to Aboriginal and Torres Strait Islander people here today. So we have a very simple code of conduct, basically, and I'm not going to read everything, but I think everyone here pretty much, well, at least people who are familiar and people who might be new pretty much, yeah. I think even for those new, there's just only one thing to keep in mind, basically, just be respectful and be nice to each other, and yeah, you'll pretty much be in the grounds of our code of conduct. And as for Python on the web, we have a few channels if you are interested in following that. We have the Melbourne Python user group, as you can see over there. We also have a presence as well on Mastodon. So if you're interested in following what the page is pretty much to keep on the latest with what's happening with the Melbourne Python user group, keep updated like with the latest meetups happening, or pretty much as well if there's any other events or anything else you want to follow that's interesting in Python, which we also post as well. Feel free to follow those as well. We're also active on Slack too, so yeah, pretty much I'm going to be sharing that in a bit as well. So for today, we have a bit of a slightly different agenda than usual. So we start with introductions about what I'm doing today. Right now, we then have Akshat Soni, who's a graduate student at Tseitkin University on RESTful API Development using Python and Django as our first talk. We then have a bit of a break for more food and drinks. We then have Tseitkin, who's the co-founder at Akshat Quantum on Intro to Post Quantum Cryptography with Python. We have a new addition for today. We have something called a marketplace. So if you are the astute observer or pretty much have already been around to some Python meetups previously, or any other meetups previously, the marketplace section is essentially a place where I will essentially call on anyone in the room who is an employer and has a job to offer in particular. So essentially, if you have a job that you want to pretty much just pitch, you have about basically 30 seconds to quickly pitch it. Just enough so that anyone in the room who is looking for a job and is interested in that role can come up to you and chat to you later on after we close up. And that will go on for 5 minutes, and we then will close up and continue networking, and at 8, doors will close. And of course, we couldn't have done all this without our sponsors. So we have Judo Bank, really great people who was pretty able to give us this great venue over here, beautiful venue. We have AWS and we have just digital people as well. So I'd just like to quickly hand over to Michael to give a bit of housekeeping on behalf of Judo Bank.
Yeah, thanks, Rinaldi. Judo Bank, if you don't know what we are and what we do, we are a bank working in the SME sector. So we are trying to become the most trusted bank in the SME sector. There's some housekeeping stuff. If you need toilets, they're all the way down the back and to your right. If they are locked, which has been in the past, please don't hesitate to reach out to myself or any of the other judo or volunteers. And if we can just make sure that we try and keep this place tidy so we can keep hosting this thing, be bins are over in the kitchen area. If you can't find them, just reach out to me or another volunteer and we'll help you. And I hope you all enjoy the talks tonight. Thank you.
Thanks, Michael. And just another call out pretty much, but yeah, feel free to say hi as well and pretty much just, start having a good conversation as well with any of the fellow Judo Bag, AWS, or GDP people around here too. So as mentioned, we're also active on Slack. We already have quite a good member base on Slack, and pretty much that's where the main place where we post updates, post announcements, have pretty much calls out to volunteers as well. So if you're pretty much interested in kind of like following with the latest stuff here, feel free to join the Slack. You can just scan the QR code. These are just some examples of some of the challenges that we have over there, which we regularly post to. And also, we always welcome people who want to get involved. So we're really thankful to all the volunteers who've already volunteered their time. Me, Rinaldi, and Kai have been pretty much volunteering as the organizers for this meetup at the moment. But we always pretty much would really love to have more engagement and pretty much more people involved in different things and helping out with different things around the meetup. So in terms of volunteering, for now we're looking for 3 different roles to fill, particularly for volunteers. First, we're looking for organizers / MCs. So essentially what I'm doing right now. So essentially if you're interested in that, feel free to reach out. Aside from that, we're also looking for both a Smart Jam speaker liaison. If you're interested in either one of those, feel free to reach out to me. I can tell you more about it. And aside from that, we always happily also welcome any sponsors who are interested in sponsoring too. And pretty much if you're interested in speaking, we never can get enough of that. We're always looking for more speakers. Well, it's essentially what provides the great content you can come to every day for meetups, right? And it's a great place to share what you've already done in your company or in your personal projects or anything. So it's always a great way to get a new forum and just pretty much share your ideas with people. So that is really about it. So without further ado, I'd like to introduce our first speaker, Akshat. So Akshat is a postgraduate cybersecurity student at Deakin University, having over 2 years of professional work experience in India, serving organizations like Global Logic, Google, and etc. His experience working on web application development using Angular, Python, and in July 23, he embarked on his journey to acquire knowledge about cybersecurity in Australia, and so far completed his first trimester at Deakin. Alongside, he's acquired Certified Application Security Engineer certification from EC Council. So let's put our hands together for Akshat.
All right, so good evening, everybody. It's truly an honor to be able to speak to the esteemed audience that we have today with us. So myself, Akshat Soni, as Rinaldi already introduced, I'm studying at Deakin University right now, and we'll be going through web development with Django today. So before we get started, this is a quick introduction, which I think already Rinaldi has covered. So I think we can directly dive into the talk. So let's first discuss why you might want to use Python for web development, because there are multiple options. So Python is you might already be using Python in some of your projects and you need to enhance your skill set. So Python is a very good tool also used for web development. Then Python is very easy to learn, and also a very great feature of Python is that it has readability. And if we follow a particular syntax with Python, that you have to follow the indentation, and that is what increases the readability. Now, when it comes to Python for web development, we have different frameworks that we can use. So we have Django, as we are going to discuss today. Then we have Fast API, Flask, and CherryPy. So let's get started about Django. So Django has been around for like since 2005, so almost 19 years now. And the first official release of Django was in July 2005, and that's when it was introduced as an open source framework, and they started welcoming contributions from all around the world. Then Django is obviously a high-level Python framework, which focuses on rapid web application development. Then the architecture that we follow with Django is called MVD. So there are different software design patterns. So one of them is MVC, which is a bit modified version that we are using in Django. So we'll dive more into it when I explain the architecture. And it is maintained by Django Software Foundation. Now, so I also told you that there are different frameworks and why we cannot use Flask. So let's go through a simple list of reasons why why the Flask will not be suitable for your project. So it is very well suited for small scale projects. So for example, if you have a data science application and you just need a presentation layer with your project, then you can of course go ahead and use Flask. Then there are no batteries involved. So what is a battery? There are some pre-built features that are supported through libraries. So Flask is very flexible with what you can use with your project. So there are no batteries involved. Then we talk about development speed. So as you have a lot of flexibility, you need to make certain decisions which can slow down your process of development. So development speed could be a bit slower. Then there are no security features as such provided with the framework itself. So you have to look for libraries that you can leverage for security features that should be integrated in your application. Then let's talk about a few things that you can consider with Django. So there is a built-in support for ORM. What is ORM? ORM is Object Relational Mapper. So what it does is you can define your database schema in terms of classes, and then you can, when you're doing the transaction with data, then you can create objects and directly interact with the database. Then it provides admin dashboard that you can use to control, to have more control over your application. You can configure the authorization, then different permissions. Then Django is very easy to adapt, and there are different features that are supported. So some of them are security features. For example, it provides SQLi injection protection as you already have the ORM. So there's less vulnerability with databases. Then it provides CSRF attack protection as well, and many more. Then we have a huge community online from the Django. So they also have Google groups. Then there are so many Stack Overflow channels that you can follow. Then there are Reddit threads where you can ask queries. Even when I started working on Django, I have faced a lot of issues because when you work with a new framework, then you do not know a lot many things and you run into errors. So where do you find the solution? So you look for communities that can support you when with your development. So Django does that. And yeah, so now let's start with the architecture. So as I was explaining that Django uses MVD. So you can see over there we have models, we have views and templates. So that stands for MVD, model, view and template, where model takes care of your database schema. So you define all the structure of your application which uses the database. So that can be the tables, the constraints that you have. Then we have the views, which deals with the business logic and how you control the database and how it is rendered to the user. Whatever the response that will be sent out to the user, it is all taken care of by the view. Then what actually is seen to the user is the responsibility of template. So you can use server-side rendering feature of Django, and you can provide the templates where the data will be rendered by the view and it will be seen to the user. Now, how it will process your app request. So when a request comes, first it comes to the urls.py, then it gets redirected to the corresponding view that we have defined. So you can define all the routings in urls.py, and that should be about the architecture. So when you create the Django project, you will have a folder structure that you should be aware, what all files are there and what it does. So we have the main project folder, then we have an application folder. So when you create a new project, you might not, you will not get the application folder because when you start planning the project and you start working on it, so you will create the application, so it will be a default structure for the application. Then we have the project folder. So in the project folder, you will be seeing a file called asdi.py, which is used for asynchronous gateway interface, which is used when you are creating asynchronous server. So that interface could be uh, used. That interface could be created using asdi.py. Then we have settings.py, which takes care of all the default configurations that we have. For example, the templates directory, where is it located, and the database configuration. Then there is different applications that we are working with or the libraries that you are using. Then we have urls.py, which works as a router for your application and takes care of all the HTTP requests that we have. And we have wsdi.py file, which will be your main server file. So it contains all the configuration that will be supporting your web server. So WSDI is web server gateway interface. Then we have the database file. So for this default project, it will provide you with SQLite 3 configurations. So when we do the migrations, so migrations, I'll talk about it when we go through the demos. So it will create a database file. Then we have manage.py, which takes care of the complete project. So for example, if you are looking to create a new application, or you want to run the server, or you are modifying your database and you want to make the migration. So it will all be configured in the manage.py. Then coming to the application folder, we have admin.py, which is responsible for the admin dashboard that I was explaining in the features. So admin.py has all the configuration that will be controlling your application. Then apps.py, if you have a configuration that is very specific to the application inside your project, then it will all reside inside the file called apps.py. Then we have models.py, which contains all the database schema and the structure for the database. Then we have test.py. Test.py is basically the unit test that we have for an application. You can write all of them inside this file. Then there's views.py. Views.py is the actual business logic part of your application. And that's about the folder structure. Now we'll go through the demos. So I have 3 demos. First will be the installation. So I'll show you how a successful installation will look like. Right. So when you create a Django project, the successful installation will look like this. And to create a project, for my demo, I have the code created, but I can demonstrate how you can create a project as well. So when you have to create a project, you can first you have to create a virtual environment which will have all the dependencies. So for example, the dependency in this case will be the Django library itself. So we need to create a virtual environment, and from there we can use okay, I think there's some technical issue with the Python library here. So the start project command that I wrote with manage.py is how you actually create a project, and then we have a start app command that will create this application folder. So for demo 2, we will see how we can render an HTML template. Right, so I have a very simple form. So we have two fields, which is a number field. And when we submit this form, we get addition. So it is a very simple example that I personally have used when I was learning Django, because there are a lot of things and it can get complicated when you are using multiple files to understand everything. So let's go through a bit of the code that is written for this application to run. So as I was saying, we have urls.py, which takes care of all the URLs that we have. So we have the admin URL, which will open up the admin dashboard. Then we have the default URL, which is the page that was loaded, this form. So it renders a template, and for rendering a template, you need to configure the application inside the settings file. So we have all the installed applications. So installed application is like basically the modules that we have inside a project. So you can configure it over here, and we have the application called as app. So I've mentioned it here so that it knows how to wire the HTML request under the hood. So it will redirect and it will come to this view that is defined here. So view is basically a Python function that we have. So we'll check if the request has come as post request, then we'll perform the addition logic. And for addition logic, we have created a Django form, which is appeared here. So Django provides a Django Forms functionality to take care of all the validations and everything on the backend itself. So you do not have to worry much on the front end. You can simply just render the template and it will take care of everything at the backend. So the forms.py, we have a simple forms class over here, and there are two integer fields as we have seen in the template as well. Now, how this form is rendered on the template. So we have a simple condition. If we have the result variable, one second. Yeah, so if you see here, we have this response that is rendered when the view is executed. So the render function will take the request, then we have a context object. So basically context is like when you render a template, it has a certain variables that it has to render. So all the variables are contained inside the context object. So for example, here it is, if the form is valid, we will append a result variable, and then it will process the data that is rendered when we submit the form. So this is how exactly it is done. And now for the third demo, so this is the third demo that we have. So in this one, it is a simple REST API. So here, as you can see, this is the Django REST framework page. So Django REST framework is the default library that is not like it is a Django library with which you can create RESTful APIs. So first we'll add the library inside the virtual environment, and then we can configure it. So we configure the application because we install the library, so it will come in as an application. So we will add that application called REST framework inside settings.py, and it will be able to figure out when we are using views, like where to find all the libraries that are included for REST framework. And this is the app again, as I was saying, that we need to configure the applications that are inside the project. So this is the application, and for the views, actually Django REST framework provides some default functionalities that we can use. So for this page, we are using view sets. So view sets works directly with the models, and when we are working with models, we have to process these objects. So first it will fetch all the data. Then when we are rendering the response for REST APIs, we need to serialize the data because the web page cannot directly interpret the objects that we have. So we'll use the serializer provided by we'll use the serializer provided by the framework. So this is a serializer. It takes all the fields that we have in the object, and the model is configured as student. So it will serialize the data and provide it to the view set, which will be rendered on this page. Now the security feature that I was talking about when we discussed the features. So you are seeing this login thing here. So what we can do is we can create a super user, which is additional functionality provided by Django framework. So we create a super user using again the manage.py file. So manage.py create super user, then you configure it. So we will perform the authentication here. Now you're seeing these warnings because it's very basic password. So yeah, we are authenticated now, and when I go to this page, it will show me the data that we have here. And why I did the authentication was that we have used the security feature, and if I directly access the APIs, it will give this authentication error. So we are assured that the application is authenticated and it is very secure. The data is secure, and it will only be shown to the intended users. So this is the third demo. Now we discussed about Django, why you might want to use Django, and the other options that we have when we are considering Python for web development. And we went through the demos. And these are some important links that you can follow. So we have the Django project where you can find the documentation. Then this is the Django repository. The second that we have, it is open for contributions. So if you are really interested to contribute to the project itself, you can join the repository. Then we have one of the channels that I personally very I love the content that they produce. So it's called Coding Entrepreneurs. So they have live demonstrations and the advanced content with Django that you can follow, and they have like all the tutorials from basic to advanced. So thank you so much. I hope you guys had a great time. And this is my LinkedIn profile, and I would really love to get some feedback from you guys on the Slack or via LinkedIn. So looking forward to connecting with everyone. Thank you.
All right, so we have time for a few questions.
Yeah,
I'm here. I'll bring my microphone around.
where can we use Django? Sorry. Where can we use Django? Please, some people don't know coding at all. Yeah. So please tell us how we can use Django.
So for Django, there is a basic requirement that you need fundamental knowledge of Python, and Django is very easy to adapt. So when you know the basic syntax of Python, like object-oriented programming, for example, you can create classes and you're comfortable with that level, then you can adapt Django, and then you can create your web applications and turn your ideas into reality. If you guys have any further questions, we still have some time, I guess.
What benefits does Django give you while coding a full stack application while comparing to using TypeScript or JavaScript? What do you think as you work in Django?
So the benefit is that The first thing is that you already know Python, so you might want to use, because there are also obviously other alternatives which are very advanced and used nowadays. But as we have more features in Django as compared to a lot of the libraries that are there. So for example, you were talking about TypeScript. So we use, I think, Express for that. Express is a framework that we can use. So that's again is like to the level of Flask that we have. So it provides you with a lot of functionalities that you can implement. So again, the development speed and things that I discussed for Flask, I think that would be more applicable in terms of the other alternatives that we have. So yeah, the feature-rich property of Django, I can say, is much more beneficial.
At the start, you said Django has a model view table template. Where does the forms sit in that?
So the form is part of the view, because we are dealing with the business logic here. So for example, the demo that I showed for the form, when you create the form, you need what do you say, a backend for that, and Django takes care on the view level for that. So yeah, forms fall into the view part of the architecture.
I guess I was just wondering, as far as performance goes, what's the difference in performance between Django and something like Express, or as far as other languages?
In terms of performance, I'm not really sure at the moment. I will need to check that. So I maybe can reply with my response on Slack to you.
Fast API is very fast.
I definitely understand the use cases that Django has, but are there any drawbacks you've noticed, any issues you faced with working with Django?
Any issues would be like when you're starting to work, it is a bit of a learning curve before you can actually like get started and develop advanced applications. So I think one of that would be like you need to invest some time to learn the framework and get up to speed with that.
All right, I think we'll cut it off done for questions for now again. But if anyone else have any other questions, please feel free to talk to Akshat. He'll be hanging around for the break. And yeah, let's give a round of applause for Akshat. So now we're gonna take a quick 15-minute break. So yeah, feel free to stretch your legs, grab some pizza, grab some more drinks, and we'll be back here in 15 minutes. Thanks all.
Solutions. So please join me in giving a warm welcome to Sam. I click the little switch on. Thank you very much. So today we'll be talking about Post Quantum Cryptography with Python. We'll first go over a bit on quantum computers and explain how they're relevant for today and a bit about what they do. Before moving on to the more practical things, such as Qiskit, which is IBM's Python library for quantum computers, as well as current post-quantum cryptography initiatives and practical applications. So first of all, what are quantum computers? Chances are you have heard about them. Maybe some of you have heard less, some of you have heard more. In general, they basically utilize quantum physics for their calculations, namely superposition. In summary, it allows them to make calculations thousands or millions of times faster than current computers, which is great for a lot of applications such as science, medicine, logistics, etc. However, it also has, because they're so powerful, they're able to break current encryption system. So if we go over the current cryptography that we have today, we have, say, RSA and elliptic curve. They're used virtually everywhere nowadays for your email, for your messages, for securing your databases, for the TLS. You name it, it's using either RSA or elliptic curves. RSA relies on prime number factorization, which is a product of two prime factors. Basically, if we really simplify it, The big number is a public key. The prime factors are the private key. The private key is used for decryption. The public key is used for encryption. For a regular computer, it will take millions of years to calculate the prime factors from the big number. So if, assuming that the prime factors are never given away voluntarily by the one who's holding the private key, the classical computer will never be able to calculate the private key using the public key. At least not practically speaking. I think most hackers will not be able to wait millions of years. The elliptic curve relies on the elliptic curve discrete logarithm problem, which is also computationally hard for classical computers. So both of the algorithms, technically, it is possible for a classical computer to hack, but it's not practical. However, for a quantum computer, there have been, while that's still in development, we already found a quantum algorithm that is able to calculate prime factors in linear time, which really shorten the time that it will take a quantum computer to break this key. So using the public key, which it has to be given away to the other party, a quantum computer would be able to calculate the private key in minutes or seconds, which is something that is very practical for a hacker. It's also the same for elliptic curves. So yeah, just expanding a bit more on that. If Shor's algorithm comes to pass, which will happen, according to some sources, we have less than 5 years. However, it's already a risk now. Hackers, as we speak, malicious actors all around the world, they're gathering massive amounts of data that they can't read yet. However, they're sitting on it, waiting for the time that quantum computers develop enough to break the data. So they're taking the public keys that the classical computers can't calculate, they wait. This means that a lot of data right now is at risk of becoming insecure. Like all the internet connection, everything, all the emails, all the messages, all the bank IDs, massive amounts of data. So thankfully, we have been preparing, like all around the world, governments, major organizations have been developing a solution called Post Quantum Cryptography, which is the development of cryptographic algorithms that are known to be secure against quantum attacks. They use different types of algorithm for their key generation and key encryption, etc. That quantum algorithm that we haven't found yet a quantum algorithm that can break. NIST, for example, which is the U.S. government's branch for cybersecurity control, they're the one who standardize post-quantum cryptography algorithms. So this is kind of going a bit more into more details. I will not go into much more details, but yeah, there are different types of post-quantum cryptography algorithms. They use, as I mentioned, different types of algorithms. There are four main types. There is a lattice-based cryptography, which utilizes shortest path algorithm, code-based cryptography, multivariable polynomial cryptography, and hash-based cryptography. For most of the focus has been on lattice-based, and those are the algorithms that have been selected that I'll go on a bit later. So why am I talking about this in Python event? Yeah, Python has played a major role in all of this, including for my own like application, post-quantum cryptography application. It has a lot of relevant libraries, both for quantum cryptography and quantum computers and post-quantum cryptography. And it just allows much more robust algorithmic capabilities than other languages will either take like significantly more space, more time, etc. It also has like a very strong community and support for such works. So I'll be talking now about Qiskit. which is an open source quantum computing framework developed by IBM. It is written in Python, and it allows you to kind of either simulate or outright reuse a quantum computer. Basically, you can either simulate the quantum computer behavior using this library, or you can outright connect to IBM's quantum computer if you're willing to pay, and use their quantum computers using that language. So going a bit deeper into Qiskit, I will not be going too much. There's just too much to talk about. But we did mention superposition. So classical computers use regular circuits, which can either be a 0 or a 1. A quantum computer has what's called qubits, which can be a superposition of the circuit, which means it's 1 and 0 at the same time until it's observed, and then it collapses into one of the states. And H-gate, which is in Qiskit, is utilized to create the superposition. So, for example, if you look at this code, let's go over it a bit. First of all, we start with a number n, just to use for the for loop, not related to quantum computers. QC is a quantum circuit. We use the IBM function quantum circuit to dedicate 4 classical circuits to simulate quantum circuits. And then we go over those circuits and we put them in a superposition using the H-gate. And then we go over those in superposition and kind of copy their value into a diagram. We check out with the diagram. There was not enough space in the slide for, but you're welcome to try out this code. It has some very cool results.
Qiskit has been, we are using Qiskit for the Post Quantum Cryptography in our API. It allows for, as I mentioned, superposition is very crucial for what's called true random values. It creates very, like most random values nowadays are not really random, they're pseudo-random. Quantum is basically as random as it gets. Some may say true random, because we didn't find out yet how we can predict their values. So it's extremely important for cryptography, and therefore that's what we use to enhance our keys. Now, I actually added this a bit last minute because there have been some major changes in the post-quantum cryptography space. In August 13th, 2024, so very recently, NIST has selected Crystal Skyber as a finalist for post-quantum cryptography. That's now the algorithm that is being recommended by businesses or industry or like public sector to use for their new encryption to replace RSA and elliptic curve. It's not exactly the same as RSA. In RSA, you will generate a key pair, and one of the keys will be used for encryption. The private key will be used for decryption. You send over the public key and keep the private key. As you can see in this diagram that I found very useful from a Medium article, Crystal Skyber works a bit differently. It's called a key encapsulation mechanism. It's used to create a symmetric key tunnel because AES, as far as we know, is quantum secure if you use a big enough key. However, the problem is the key distribution. Like, how do you get the same key across both parties without it being observed by a quantum-enabled malicious hacker? So as you can see, the client will be generating, kind of starting off the same. They'll be generating a private and public key. They will send over the public key to the server, but that's where it gets a bit different. The server will then what's called encapsulate the key. It does some calculations on this public key to generate a shared secret, and then it encrypts that shared secret into a ciphertext. They send over back the encrypted ciphertext because like that ciphertext can be observed, it's encrypted, it doesn't help any malicious actors to see it, back to the client, who can then use the private keys that they kept to decrypt the ciphertext into another shared secret. And as you can see now, we got the shared secret, the same shared secret on both sides, and they can do AES for symmetric encryption, quantum safe symmetric encryption. So yes, it's not really as easy as 1, 2, 3, but using an API, for example, it
could be a bit easier when you don't have to handle all the lattice-based mathematical calculations. So for example, in our project, Tseitkin, we provide a Post Quantum Cryptography API that utilizes Crystal Skyber for Post Quantum Cryptography. It utilizes Fast API for more like performance and security. We have been using Django a lot as well, but the backend of the API is Fast API. And this is just an example of using Python for the Tseitkin API. As you can see, we have the API URL, tseitkin.com API KC, which is our endpoint for Crystal Skyber. First, we generate the keys and turn them into JSON, and then we use those keys in order to encapsulate the key. The private key has stayed in our servers. It's never shared with anyone for extra security. The verification key and verification signature is kind of something different. It's a digital signature to ensure that the public key hasn't been tampered with. That's also a quantum-safe digital signature called Crystal Dilithium, which is outside the scope of this presentation. So yeah, you use this API call to use the public key to encapsulate the key and generate the shared key, which is shared key 1. And then the other side calls it decapsulate key endpoint. We're using the ciphertext and the public key to generate the second shared key. So yes, the takeaway is quantum computers are very close, much closer than we think to becoming commercial. It's advancing in an exponential rate, which is something that is hard to grasp sometimes. Like it starts off at 0, it then goes to 1, and then 2, and it feels very slow, and then before you know it, it's running. So we really need to start preparing for cybersecurity, which is why the organizations around the world have started to promote new types of algorithms, which again, thankfully they have done that. And there are solutions all around that can be utilized, for example, our API, and that helps clients, public sector, private sector, to upgrade the security to post-quantum cryptography before it's too late. Thank you, and now I'll be demoing the app. Yeah, so I got a command line tool. It's an open GitHub if you wanted to try it out for yourself. I'll just kind of quickly demonstrate it. Hopefully it doesn't break as I show it. So for example, I run this command, generate the keys, store the public key in public key.txt, store the verification signature in signature.txt, and the verification key in verif.key.txt. Store them successfully. If you look, those are like the keys that have been stored. Now if we want to encrypt, use those keys to encrypt. I want to encrypt the text, hello world, using the public text, and store that encrypted message in encrypted/message.txt, and use a verification signature to ensure that the public key hasn't been tampered with. So now if we look into our encrypted text, as you can see, this is hello world, but it's not a hello world that you can read, and hopefully no one else. And if we now decrypt it, we read the message.txt and store the decrypted text in message_plain.txt. As you can see, I'm creating those files as we go. There we go, we got our hello world back. So hopefully, this is what the hackers will see, and this is what the intended recipient will see. And yes, that's pretty much it. Anyone have any questions?
How much do you use your service and do you actually use what quantum
So our services, the first 1,000 API calls are for free, so you can test it out. And then it's $1 per 3,000 API calls, because it's one key generation, one encapsulation, and one decapsulation. Keep in mind though that every like of those trials calls are meant to secure a session, not a message. So you will create like a shared key to secure your sessions instead of like making many more API calls to secure every transaction. So it's really like quite affordable compared to most other cybersecurity services.
What I understand about quantum computers is that it requires superconducting materials, if I'm not wrong, to operate.
Yeah, I believe so.
So I mean, that I think is the biggest barrier why quantum computers are still under development, right? Cool. So what's the role of the recent rise and fall of the room temperature superconductor that was like supposedly invented and then it was a fake at the end? But is that something that really? Oh, I'm sorry, it's a bit off topic, not exactly what Python relates to, but like what I would assume is that does it play a big role in hackers getting access to quantum technology, or is it something unrelated completely?
So was the question that like how do they get over the challenge, or like the superconduction?
You need superconductivity to perform quantum computing at the very basic level. Yeah, and for that you need to cool down materials at a very low temperatures. But if you were to invent something as LK99, which is a room temperature superconductor, you can basically manufacture a quantum computer as like we do at like a regular computer. So what's the role of that compared to security? Because right now the only reasons hackers cannot get access to our data is because they don't have access to this technology.
Yes. Well, we don't know how close we are to generating a quantum laptop, for example, that everyone can access. However, I personally believe that the first to access this quantum computer for malicious reasons will not be an individual. It will probably be like a terrorist organization or maybe even a malicious government. There are plenty of those who commit hacks all around the world. So for all we know, even before we have the temperature room superconductor, the Q day, as they say, will happen. And also, I'm sorry, I forgot to answer your second part of the question, which is how do we access the quantum computers? So as mentioned, you can access IBM's quantum computers via cloud to kind of have them perform the calculation for you so that you don't need to buy your quantum computer.
Just on that, so anybody's able to access IBM's quantum computers. Is there anything to stop hackers from getting into them?
Technically, no. You can access them now. However, I don't believe they are powerful enough yet to break RSA. They have become functional. I think Google has achieved what's called quantum supremacy very recently, which is a quantum computer that's more powerful than a classical computer. However, we didn't get to that stage quite yet.
I think to answer your question, I think IBM gives you a fixed number of qubits for free. So you can only do things with like 1,000 or 2,000 qubits, so you can't perform huge operations just yet on that.
If they've already got all of our encrypted data, is it not a bit too late to do all of this? Because they'll have that data and they can just decrypt it.
Well, that depends to what type of data they have accessed. Most of the data they harvest is public keys. You could, or for example, sensitive information along with those public keys. Those things can be changed, and it's recommended that it's going to be changed. That's going to be one of the first things. One of the first things we say when we get a client. We say like, okay, time to change all your other data now. Make sure to clean up the harvested data, so to speak. So it's not. I don't know if it's too late or not. It depends on how careful the client was to begin with. The party, it's usually not too late.
In the graph that you showed before, that is you send in to the server, and then the server sends back a kind of recrypted message, right? Who says that the malicious actor can pose as the person receiving the message and decrypt it, and then send back the message?
Yes, that's exactly, that's a good question. As you could see, when I showed the demonstration, apologies for not explaining it a bit further, we had the verification key and signature key included in those API calls. That's exactly for this purpose. There is a digital signature that confirms the public key hasn't been tampered with. Otherwise, one of the parties will be able to tell, okay, this is not the right public key. We cannot use this for the shared secret. That's your question?
Any other questions?
Yeah, I've got a quick question. Normally when we go to more advanced security, I think you have more progression of RSA keys and that, we typically have degradation in performance. So only by offsetting with faster silicon, for example, that we can perform operations faster. What's the difference in performance between traditional sort of RSA-based security and quantum-based security for normal everyday operations?
So judging by performance test on our API, there is barely any change. The keys are a bit bigger because they need to be bigger in order for the key. I mean, I guess you have to do some sacrifice for security. There is a triangle, cost, security, performance, and you can't have it all, unfortunately. However, in terms of performance, there is barely, we tried, for example, a file upload. There was no difference between just regularly uploading the file and using our API to encrypt the file before uploading. So thankfully, the performance had been taken into account in those new algorithms.
Yeah, I guess the takeaway is that we don't have a 10 times performance for a far more secure platform.
Yeah, it's not faster, unfortunately, in terms of performance. It's more secure and negligible slowness.
You mentioned that Qiskit can simulate quantum computing. Can you expand on that, because it doesn't really, I can't make sense of it right now. That's all.
Sure. So as mentioned, you can if we go into the slide, you can dedicate a few of your circuits to simulate a quantum circuit. I'm not sure, don't quote me on this, but I think it's 2 circuits for every qubit you simulate, which is it's exponentially going, you can only dedicate so many circuits before it blows out. It basically uses those circuits at a time to simulate a superposition, or simulate how it would act randomly. It's not as random as true quantum randomness, but it simulates that randomness.
So it's a mathematical simulation for a physical.
Yeah, it's basically a mathematical one using the circuits.
All right, any more?
I'm fairly new to this. Are you able to explain just on a basic level how a quantum computer can break something like an RSA algorithm? How is it that it's different such that it can do that a classical computer can't?
Yeah, sure. So as mentioned, the way that it makes calculations a bit different. A regular computer would have to just guess, okay, is this the right prime factors? No. Is this the right prime factors? No. This is a very slow process, because it have to guess all possibilities. And there are so many possibilities for a very big number that is, it's a bit, I can't really go too much into how Shor's algorithm works, which is a quantum algorithm that breaks that encryption, but it utilizes a superposition to it performs all of the possibilities at once, and then collapses into the right one, so to speak. It doesn't always collapse to the right one, but it collapses, it does all possibilities and then collapses and so on until it gets the right one. That's a bit of a faster process. You can look, I can send you a video that explains it in a visual way and dives into it, because it takes around 20 minutes to explain it after the presentation, if you want.
Any other questions?
You said there was an organization that chose Crystal Kyber. Can you elaborate on who that organization was, if they have an authority, like what their authority is on authentication?
Are you referring to NIST?
Yeah, I might be. I'm not unfamiliar with the field, but yeah, I'd like to learn a bit more.
Yeah, sure. So NIST is a branch of the United States government that specializes in cybersecurity, digital security, etc. They have been on the forefront of standardization of encryption, cryptography, and security in general. They are funded by the US government, run by the US government, and are basically potentially one of the the most trusted source in the world for this.
All right, any other questions? Okay, then we'll close it there. Once again, let's give a big round of applause to All right, I think we'll close it off there then. So yeah, pretty much, thank you again everyone for coming to the meetup. Again, this kind of have been run the way it is without all of you pretty much just coming down each month, pretty much going down and yeah, just kind of like getting along with the community. So yeah, always great to have you around. And yeah, again, as I mentioned before, if you are interested in either volunteering, sponsoring, or yeah, any of the ones I mentioned before, or speaking as well, yeah, feel free to come down in front. Yeah, talk to me for a bit, and yeah, pretty much I'll point you in the right direction, and we'll be glad to pretty much have your assistance as well because this is pretty much run a lot by volunteers and speakers after all. So yeah, we're more than happy to pretty much have your help as well if you're interested. So yeah, without further ado, pretty much I'll close up the night, and feel free to stick around a bit. Doors close at 8, so try to shift yourselves a bit towards that time to outside the door as well. But yeah, aside from that, thank you again, everyone, and yeah.